Assalamualaikum warahmatullahi wabarakatuh. In a very good day to everybody. Alhamdulillah, we have done chapter 1, we have done chapter 2. Now we are moved to chapter 3. Basically, it's a very important the units of measurement. In the chapter 1, we need to define the length, mass, all the SI units. And then also for the second chapter is a force vector. Is very important. We need to get the resultant of forces when there are several forces applied on acting on in one point. So now we want to move to new chapter number 3, which is the equilibrium of a particle. Okay, the objective of this chapter is basically we need to learn the concept of the free body diagram for a particle. So after this, you should be able to draw the free body diagram for a particle, and then we solve the particle equilibrium problems using the equation of equilibrium. Okay, the outline for this chapter, basically we have the three topics. The first one is condition. We need to determine, we need to understand, we need to figure out what is the condition of equilibrium of particle. Then after that we move to how you want to draw the free body diagram. Then we need to use the Copeland system based on SY axis. Okay, basically when you're talking about equilibrium means generally we're talking about static, no motion, not moving. The object is not moving. You can see the static condition. But generally, when we're talking about a particle at equilibrium, if they have two conditions, first one is at rest, doesn't move. Then the second one is moving at constant velocity. Although the object is moving, but why you can stay in equilibrium? When you say when draw back the Newton's first law of motion, the total force applied acting on that particular point is equal to 0. Basically, the total force when we apply the total force, the resultant of total force acting at one point is equal to 0. So meaning that the particle is in equilibrium. So but here when we are talking about a 0, so all the forces the 0. So no, after we sum all the forces acting on one point, the total one is a 0. So that's why it's equilibrium. Okay. But when we are talking about the Newton's second law, F equal to ME, because the F equal to 0, so if F equal to 0, so ME equal to 0, then E is equal to 0. So acceleration equal to 0. So what is the acceleration to 0? The particle if the particle has a acceleration equal to 0, meaning that the particle is moving in constant velocity. So final velocity equal to initial velocity. So acceleration is the final velocity minus the initial velocity divided by interval time. So that's why it's the E equal to 0. So meaning that if the F equal to 0, so that's why the condition of equilibrium is they have two conditions, at rest and moving at constant velocity. Okay, so now how you want to draw after we determine the particle is in equilibrium. So we need to draw the free body diagram. So basically the free body diagram is we need to represent all the unknown forces or any forces that act on the body, and then we need to sketch showing the particle free from the surrounding with all the forces acting on it, meaning that the object is in equilibrium. So here we have two common connection, two common problem, two common situation for these equilibrium particles. First one is the spring and cables pulling. Okay, so now how I want to draw the free body diagram for spring. So we have the linear elastic spring. So we are consider linear elastic spring. So meaning that the change in length, for example, we have this spring here. So originally, before we pull the force, we apply the force here. This was a pulling tension force. So the length is unstretched, L0. Okay. When we apply the force, pull or tension force here, so the spring is elongate. For example, the plus S is the length. Okay, so change in the length is actually directly proportional to the force acting on it. So this one is the meaning by the linear elastic spring. So the change of length is directly proportional to the force. So spring constant, because the spring, we have the spring constant or stiffness K is defined as elasticity of the spring. So how you want to determine the magnitude of the forces, or what is the actually relation between the force and also the stiffness K, and also with the change in length S here. So given by the magnitude of force when the spring is elongated or compressed is equal to the stiffness K, stiffness K multiplied by the S, multiplied by this change in length. Okay, second one is the cables and pulley. So let's say we have the pulley here. So now we have the cable. So we have the tension, because this one is connected, the cable is connected together. If you have the tension is actually equal, for example, it's depending on the problem. So cables or cord are assumed negligible weight and cannot stretch. So we are in our study here, we made an assumption the cable is negligible weight, okay, and also cannot stretch. The tension always act in direction of the cable. So the force is direction, this is downward, it's away, it's actually away from the pulleys direction to the cable, this direction here. Tension force must have the constant magnitude for equilibrium, so we need to have the magnitude, constant magnitude. So for any angle theta, the cable is subject to a constant T. So we can determine the theta based on this okay, we can see here if we have the tension here, so we have the angle theta here. So for any angle theta, the cable is subjected to a constant T. Okay, I think we can we stop here for our first session on equilibrium of particle. I just want to recap. So we need to understand what is the condition of equilibrium. So in equilibrium, it means the particle is, if the particle is at rest or the particle at the moving in constant velocity, there is the two conditions for the equilibrium of particle. So we have the two common connection in this equilibrium particle is the spring and cables and pulley. So spring given by F equal to Ks, meaning that the change in the length is the direct proportional to the force. And also we have the cable, so the direction of the tension is the direction of the cable, or away from the pulley here. So we have the constant T for any given angle theta. So see you again, see you in the next session. We can see the problem and example in our this topic, inshallah. See you next time. Bye bye.